Hi, boys and girls. Welcome back to Mr. Cedarbach's geometry class. Here's what we were working on today. So go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. What, you think it's weird to wear a bike helmet with a shirt and tie? Whatever. Let's get started. Lesson 7.2.6. What can I prove? Explore, conjecture, prove. Now, before you get started today, you're going to need to take out a few materials. In addition to your pencil and your graph book or your notebook, it would be good to have a ruler or some kind of straight edge that you can use to take measurements. As you get started, I would like you to read the lesson introduction and problem 103 and complete A and B. Okay, so hit pause, go ahead and go through those, and hit play when you're ready. So by now you should have explored and written a conjecture about the relationship between segments DE and AB. Now if you used your ruler, you could have brought it up and seen, okay, if I look at this, well, based on this unit of measurement, DE is 2 units and AB is 4 units. Okay, so I'm going to conjecture that DE equals half the length of AB. I could also write this as AB equals twice the length of DE. Letter C, prove. Sergio wants to prove that AB equals 2 times DE, what we conjectured from the last problem. However, he does not see any congruent triangles in the diagram. How are the triangles in this diagram related? How do you know? Prove your conclusion with a flowchart. So he says triangles plural, so it might help if we separate these two. So we have the larger triangle, CAB, and the smaller triangle, CDE. So those are the two triangles. Obviously, they're not congruent, but might they be similar? Now, if you remember, there are 3 theorems we use for proving similarity. Angle-angle similarity, side-angle-side similarity, and side-side-side similarity. By the given information, can we prove that they're similar by any one of those 3? Let's take a look. So, angle-angle requires us to find 2 pairs of congruent angles. Now, I know that that angle C is congruent to that angle C, right? And we can hold it over. It was a copy of itself, so obviously those are congruent. But do I know that any of the other angles are congruent? Now, yes, I could take this image and I could move it around and measure and say, oh, those are congruent to each other. But really, we need to use whatever markings they give us in this problem. And since they don't mark any of the other angles, or they don't tell us that the lines are parallel, we don't know that other angles are congruent. So that eliminates angle-angle. Now, what about the side ratios? Do we know anything about the sides? Well, they don't give us numbers, but they give us these tick marks. Now, I'm going to make up a number. I'm just going to come up with a random number 3, all right? That's not 3 units, I'm just coming up with a number. If that were 3, then this would also be 3 because of the tick marks, which means AC would be 6. And that shows us a zoom factor between CD and AC of 2. And then let's say this over here was 5. Again, I'm just making that number up. Then this would also be 5, which would mean CB would be 10. And so we'd have a zoom factor from this side to this side of 2 as well. So we have a common side ratio of 2. Do we know what the third sides are? Now, they don't give us any tick marks on these two sides. So while we conjectured that one is half of the other, or there's a ratio of 2 as well, we don't have any tick marks, so we're not going to be able to say side, side, side. We only have 2 given side ratios. But can we use side, angle, side? We have 2 common side ratios, and we know that the included angles, this angle here and this to itself, which is this angle, those are congruent. And so side, angle, side similarity works. Let's write it in a flowchart. Now, since I made up these numbers 3 and 5, I'm not going to use numbers in my flowchart, but I am going to use the sides. So I could say side AC over side DC equals what? 2. And then I could also say that side BC over side EC equals 2. And then the included angles, angle C, is congruent to angle C. Now that's enough information to make the conclusion that triangle ACB is similar to, remember, not congruent, similar to triangle DCE. By side, angle, side similarity. Now remember, we're trying to prove that AB is 2 times DE. We haven't done that yet. We've just proven that the triangles are similar. So we're going to take this and extend this flowchart. So if triangles are similar, what then do we know about that other side ratio? If they're similar, what must be the ratio of AB over DE? These two sides, AB and DE. Well, they must have the same ratio as the other corresponding sides if the triangles are similar. So AB over DE must equal 2. And that was a weird shape to create. I'll just leave it like that. Now, we really could leave it like this, or we could take this one step further using algebra. I'll write it over on the side here. If AB over DE equals 2, we could multiply both sides by DE. That would equal 1 over 1, and I would have the result of AB equals 2 times DE. If I gave a reason for that, what I did here, when you multiply something by both sides of an equation, that is the multiplication property of equality. I didn't write justification for the other bubbles, and in this case, that's okay. This is a good enough flowchart to prove our conjecture. Moving on to letter D. What is the common ratio between side lengths in the similar triangles? Use this to write a statement relating the lengths of DE and AB. We already did that. We did it up here. You don't need to do it again. So let's move on to E. Now Sergio wants to prove that DE and AB are parallel. Use the similar triangles to find all the pairs of equal angles you can in the diagram. Then use your knowledge of angle relationships to make a statement about parallel segments. Okay, we already proved that these two triangles are similar. And so how do we prove that lines are parallel? Well, we need to prove something about the angles. Now we know if they're similar, this angle here, angle A, is congruent to angle EDC. Is that enough information to prove that the two lines are parallel? Look back at your angle relationships worksheet. You can also look at the link in the description of this video to identify which angle relationship we could use. So here we have the angle relationships created when a transversal crosses two parallel lines. Which of these angle relationships apply in this problem? Hit pause, look through them, and then play when you think you found it. Hopefully you identified corresponding angles, angles in the same position at different intersections of the transversal. Here it states that if lines are parallel, then corresponding angles are congruent. The converse is also true, that if corresponding angles are congruent, then lines are parallel. And that's what we have in this problem here. That DE is parallel to AB by the corresponding angles converse, meaning if corresponding angles are congruent, as they are here, then lines are parallel. Let's add this now to our toolkit for the entry on a mid-segment. This is on the second page of your toolkit at the bottom. Let's start by defining a mid-segment, which is the segment joining the midpoints of any two sides of a triangle. And as we proved in the previous problem, a mid-segment is parallel to and half the length of the third side. Now I want you to take the ruler or the straight edge that you got out, and we're going to use that to find the midpoint of every side of this triangle. So line your ruler up and find the midway point on each side and put a dot there. Now we have our 3 midpoints. We're going to show that these are midpoints with tick marks. So since those 2 segments are congruent, that means that point is right at the center of that side. Now I'd like you to draw the segments connecting those points. And let's label these. We'll call this A, B, C, D, E, F. So we'll take one of these as an example. DE is a mid-segment. And as we proved in the previous problem, as a mid-segment, DE the length of DE is half the length of AC, and segment DE is parallel to segment AC. So since it's half the length, I can put those same 2 tick marks because this is the same length as this. And they're also parallel, so I'm going to add parallel arrows. Now if you notice, DF is also a mid-segment, and the third side would be BC if we're looking at DF as a mid-segment. So I can add 3 tick marks to that to show it's half of BC, and I can add parallel arrows because it's parallel to that side. Go ahead and add the tick marks and the parallel arrows to side EF. And there you have examples of the mid-segments of a triangle.